All right. We were talking about circles. We were making a circle class, which is what this was here so far. It's fairly empty. And then we made instances of circles. So we write the class once, which is like the blueprint. And then based on the blueprint, we can make as many circles as we want based on the class. And an instance of the class, we call it an object. And what we talked about last time is, well, we didn't need the constructor or initializer here. We didn't need it, but it was fairly useless without it. We can create an instance of an object, but we couldn't really do anything with it. Here, what this says is, okay, we're creating a class called circle, and then we're writing the constructor. And it has to be called underscore underscore init underscore underscore, and it must contain at least one parameter, and we call that one self. And self is a reference variable to the instance. So when it's a class, there's no instance. But when I went and I wrote, hey, circle A equals circle 1, what happened was self was the implicit argument. So this would be the instance being created, a reference to the instance being created, which in this particular example would be an alias for circle A. Circle A will be a reference to the circle being created here. Self will be a reference to that same circle. It's an alias. But the self one is like internal within the class. When I run line 2 here and I say circle B equals circle with 5 in it, circle B will be an alias for self as well. Self is a reference variable to the current instance. So when I call, like on line 1 there, circle A equals circle 1, the implicit argument is just it's there, and then radius 1. So we actually only gave it one argument for that special method called a constructor. We gave it one argument. Really there's two, but we only explicitly give it one. Here, the value 1. And that parameter's value is 1, radius is 1. And then we go and we say, okay, self.radius equals radius. Remember how variables have scope. Parameters have scope. If I have a function with a parameter called ABCD, and I try to access that value through the parameter ABCD, the variable ABCD outside of that function, it doesn't exist, right? That shouldn't be, this is not novel. This is something we talked about months ago. So let me show you real quick. This function does literally nothing. And if I call ASD at 1, and then I try to print, it's not going to work. It's going to say, well, that variable is not defined, because it only exists inside that function. If in here, I were to say, it works just fine, it prints out the 1, but then when it gets down to line 5, there's an issue because that variable doesn't exist. So we've got a bit of a problem. I want this object to remember its radius value. If I give it just as a parameter, that value of radius, on line 7 there in the parameter list, radius, it's going to disappear once the function's done. So we have to assign it to be one of the object's fields or attributes or whatever we want to call it. Fields, attributes, these are just variables that are associated with an instance of the class. They're associated with a specific object. So here I'm saying, okay, self, because it's a reference variable to itself. So the object I'm creating here, because it's the initializer, you have an attribute called radius, and your value is going to be whatever was passed to the constructor through the parameter radius. That way, later, when I go down here and I hit run, let's get rid of this block here. When I ask circle A, what's your radius? Well, it's 1. Why? Well, because I set it to 1 in the constructor right here. Why is circle B 5? Because I made it 5. Both of those objects, both of those circles have a radius, but their values can differ, which is fine. That's normal. That's to be expected. So although these values have the same name, these attributes have the same name, they are entirely independent from one another. Any questions so far? This really is just a recap of what we did last time. So if you got a question, now's the time to ask. Now you can go and change here. Get rid of the comments because they're not relevant anymore. I can go in and I can change circle A's radius by saying, okay, circle A dot radius, well, now you're equal to something. But this is not really advisable. More on this later, but this goes back to the idea of mutability. Our objects are mutable. I can go, after it exists, I can go and change something about it, like its radius value. But maybe I really shouldn't want to, in the similar way that just because like the lists were mutable, sometimes it's nice to think about them as if they were immutable. But more on this a little later. So there's the constructor, and then we added a constructor with an argument, or a variable, a parameter, and so on. Cool. Okay, any questions? All right, so that's, that constructor is a method. It is. But it's a special method. Your classes only have one constructor per class. Yeah, it's a special method. There are other special methods we're going to look at. There's other methods that are like those magic methods or dunder methods. But you could also have just your general purpose methods, just kind of how like a list had an append, right? We could ask the list to append something to it. So the circle class has an attribute radius. But as of now, that's all it really does. It's kind of a roundabout way to store a radius value. It only stores data, which is fine. But some other features of a circle we might want to know are its diameter, area, and circumference. We could probably add to this list if we wanted, but that's basically what we need. Now, it's possible to assign these values to attributes, but we don't really need to, because all we really need is the radius. And maybe when the constructor's being made, like when we call the constructor, we should just calculate these things and store them. You know, we could do that. But we could write a function or a method for a circle to return its diameter, its area, or its circumference. These values aren't stored, though. They're not attributes, but we can calculate them based on the one attribute we know, the radius. So here's an example. Now here I've completely not written the init method. You would have it, but I've skipped it here for brevity, because otherwise it's just going to get way too big. But here we go. I'm going to go add another method to our class. Oops. There. Diameter. Diameter actually doesn't need any parameters other than a reference to itself, other than the implicit argument that is the instance that's being called on. So we don't need to provide this method with any additional argument in order to calculate the diameter, because we just ask the circle, hey, what's your radius? It's going to say whatever it is, and then it multiplies it by 2, and it returns that value. So if I run this, now this class has the diameter method, and now when I say print, here, there we go. Circle A's diameter is 2, because, 2 times 1 is 2. And circle B's diameter is 10, because 5 times 2 is 10. Right? The diameter is just twice the radius. So there we go. Now, if you're looking at, well, hold on, that function or method, whatever you want to call it, you didn't give any arguments to it. But I'm looking right there, and there is something in the parameter list. And you're right, but you don't add that because self is the implicit argument. It is this. Circle A is self. It's an alias. Circle A is a reference variable to a circle. Let me put it this way. You're going to be my volunteer. Okay? You're a circle, and you have a radius of 5. Okay? You know that. And I'm going to access you through a reference variable in my right hand that says circle A. So when I say circle A, what's your radius? 5. Exactly. Right? Now, when I say circle A, what's your diameter? You go, okay, well, hold on. What's my radius? So you have a reference variable to yourself. So you say, what's my radius? Oh, it's 5. And the diameter is 2 times the radius, so it's 10. So when I ask you diameter, it's 10. I have a reference variable that I use to access you, and you have a reference variable to yourself to access yourself. That's how you access things about you. So that's how it works. Did that help clarify things, hopefully, a little bit? It'll get a little clearer as we get more used to using it. A lot of people have an issue with the idea of self at this stage only because they get stuck to thinking, what's the point of this, though? Why would I need this? But it gets a little clearer as we go. The method is not overly sophisticated. The diameter of a circle is twice the radius, but you'll notice, once again, the use of the self-reference variable. Every method that belongs to the class must start with a self parameter. It must. Since we're accessing the specific circle object's radius, we make use of a reference variable self to access their own radius, that instance's radius. And then I'm adding 2 more methods here. I'm adding one called area. It's pi r squared, because that's how you get the area of a circle. And circumference. 2 pi r is how you get the circumference of a circle. Now, this isn't going to work because I don't have math. So I'm going to have to go and import math. And once again, I can go down here. And now we have added more functionality to our circle object, to our circle class. So we can create a circle object, and the circle will know its area, and I can also get its radius, or a circle will know its radius, and I can also get its, in addition to its radius, its diameter, its circumference, its area. Really easy. I wrote those methods there. And look, watch. If I go down here, Colab is going to be smart enough for me to say circle A dot. It's going to be like, well, do you want the circumference, area, diameter, or the radius? Colab knows now, oh, well, based on the class that you wrote, this is what you have access to. Isn't that neat? I think it's pretty cool. And that's basically it to start making objects. You start with a class, your object name, your class name. You've got your initializer, your constructor. And then you have your attributes, the values, the data that that object should store, and the methods, the functionality that should be associated with instances of that object. Great. Now, be mindful that if I wanted the radius is not a method. It's just an attribute. So I don't write the parentheses there. In the same way that I don't add parentheses to any other arbitrary variable, right? If I said g equals 8 and I wanted to print g, I don't do g like this. That's silly. That's for something that's callable, right? The parentheses. Radius is not callable. It's just a variable that's associated with an instance. It's an attribute. But diameter, area, and circumference are all methods, meaning that they might take arguments. They don't. We didn't write them to take arguments, explicitly at least. And so we need the parentheses there. When calling circle A dot area, I'm asking the circle object referenced by circle A to calculate and return its area. Similarly, when calling circle B dot circumference, I'm asking the instance circle B to calculate and return its circumference. Really, the instance isn't circle B. That's kind of, I'm being a little lazy with my words here. Really, it's the reference variable called circle B. The circle instance that the reference variable circle B references, I asked to do that thing. Because circle A and circle B aren't circles. They're reference variables to circle objects. And with that in mind, what do you think when I hit run here, based on everything we've learned, what would you expect to get printed out? An address? That should make perfect sense to you by this stage of the semester. I have two aliases. Circle C is just an alias to circle A. Because circle A isn't a circle. Circle A is a reference to a circle. I created another reference variable to that same circle. I modified that same circle through the reference variable circle C. And then when I accessed that same circle through the reference variable circle A, it was modified because I only modified that one thing. This works the same way as like the lists, right? Yeah.
Why, when we defined the radius computation, did we put in it?
The radius compute, well, there was no radius function. This is the constructor. This is a special method that whenever you create an instance of an object, this method gets run. And it includes any setup code. And the only setup code I wanted was I wanted to be able to give the constructor an argument, and I wanted that argument to become that instance's radius value. I never call init directly. It all happened right here. This is how I ultimately call init. I didn't call init, but by saying class name, that goes and calls the init for us. That's just the way it goes. And the one value in there, that 1, or the 5, is the radius parameter. And that's how it'll work. And then, okay, the radius parameter, and then we go, oh, self.radius. Well, that's that instance's attribute called radius. I take that parameter value and actually just associate it with that. Be aware that what I call this here does not matter. It matters in the sense that you want a good name. But the fact that it matched what this is it doesn't matter at all. It does not. If I were to rerun this and rerun this, it's going to work just fine. Did that answer your question? Yeah, kind of, maybe. And like with circles, or like with lists, I can say hit run. No, circle C. No, circle C. Is will also work to tell you if they are aliases for one another. Now what's interesting here is I never actually told a circle what it means to be equal to another circle. All right, here's a note. What do I have here? Consider circle A dot area. The variable circle A is a reference variable to just some circle object somewhere in RAM. I'm asking for that instance to calculate and return its area. Here, circle A and the self variable within the class are referencing the exact same circle object in RAM. When looking at the area method's code, it makes use of the attribute radius, which is accessed via a reference variable to the instance of the circle. I'd already said this, great. Like with anything we do with code, we gotta write our tests. If you haven't been writing your tests, you haven't been writing your code completely. So I want to actually test the circle object. I'll just go up to this cell. Now, it's going to be important that the tests are not contained within the class. See, it's unindented. That's important. But here's what I'm going to say. I'm going to say circle 0 is a circle with radius 0. Its radius should be 0. Its diameter should be 0. Its area should be 0. Its circumference should be 0. And then a circle with radius 10. Its radius should be 10. Diameter should be 20. And then I'm doing that check that it's close enough to what I expect it to be because floating point numbers. If I run this, they all pass. Looks pretty good. So the reason I'm emphasizing this here is, we wrote our assert tests for our functions, we could write our assert tests for these objects just the same. But you might have noticed, and this was like the case on assignment 2 as well, you may notice that like we're starting to hit the limit of the usefulness. Usefulness isn't the right word. We're approaching the limit of how comprehensive our tests can be with these simple assert tests. And this will become a little clearer as we go. But some of these tests require a little bit of setup in order to actually do the test. When you're testing a function, usually it's just like, okay, function, here's the arguments, here's the expected output. But in order to test the circle, I needed to create a circle object, right? On line 55 and on line, I'm guessing 49, I needed to make instances of circle objects before I could start calling methods on them to actually test, right? Not a big deal, but there was a little bit of extra overhead we had to account for because our code is becoming sophisticated enough, for lack of a better term, that these simple assert tests are starting to not quite be sufficient. But this will become clearer in a topic or two. Okay. Circles, we just defined a class circle. Before defining the class circle, we couldn't make instances of circle objects. They didn't exist. But we wrote the class, and then based on how we wrote the class, we were able to create instances of circles, assign them values for their attributes, the radius, and tell them to perform some functionality, like calculate your radius or your diameter, area, and circumference. That's a lot that we just saw. That's a lot of new stuff. The good news is, now I'm not telling you this to I don't know. The good news is, when you look at this, most of this code is comments, right? Let's get rid of the comments. Just to really emphasize how not, and get rid of the test too for simplicity. I mean, look at that. There's really not a lot of crazy stuff going on here. And so the good news is, when you start defining your own classes, it's really not overly complex. The overhead of the amount of Python code you have to write to make something, and like to define a class, is very low. That doesn't mean it's trivial to start doing it, nor does it mean that I expect you to look at this and be like, oh yeah, I could do this now. No, absolutely not. There's a lot going on here. The good news is, I think we can look at this and agree, okay, there's really not too much. But the difficulty now for you is to get used to writing classes and used to creating instances of objects and using them. You've been doing that already. Every time you make a list, you've made objects and you've called methods on them. Good. Well, now you'll be doing that with the classes you yourself write. Any questions? Usually there's a lot of questions right now, so if you have one, ask. Yeah.
For classes, is it usually just
Honestly, it usually is just a logical grouping of data and functions. Now, it can get heated between programmers who will argue whether you should or should not have certain functions and whatnot in the classes and whatnot. But in general, you're absolutely right. It's just a collection of functions that are associated with that object. We call them methods. and data. And then you might say, like, well, why even bother making diameter a method for the circle class? Just make diameter a function that takes a radius and returns the diameter. Yeah, you could do that. Or you could make it a method that it's associated with the circle, and you could ask the circle what your diameter is. Same idea. It's just how I coded it. Functionally, it's the same. How I go about doing it, though, a little different. But yeah, that really is all it is at the end. Now, that's not to trivialize it. Obviously, when you're learning something new, it can be a little tricky. But sometimes programmers, I find sometimes new programmers, they have a bad habit of listening to bad programmers. Maybe a programmer who's been doing it for maybe one more year than you. And maybe they didn't like objects. They're like, oh, you're learning objects now. Oh, that's really complex. That's crazy. That's really hard. And then the problem is you, the new programmer, is like, oh, you start getting in your head, oh, this must be hard. I'm going to have to start working really hard to understand all this stuff. No. I'm not saying it's easy. I'm just saying it's not too bad. Don't make this out to be a scarier beast than it really is. Remember, programmers are stupid. If it was too hard, we wouldn't be able to figure it out. So it has to be kept simple for us. Other questions?
Let's say you were making a class of like a rectangle or something. How do you give it the length now?
Okay, first I want to check to make sure that's not exactly what the next one is about. Sphere. How about we go with the sphere one, and you'll see in this particular example, when you see that, how many attributes would you guess this class has? 4. You're right. Look at that. You're an expert already. So let's just go with this, and you should be good to go. Before I do jump into that, though, I want to take a moment and see, does anyone else have any other questions, though? All right, so we wrote a circle class. Simple. When talking about it, we saw how to write a class, how to write and make use of a constructor and assign values to attributes. We saw how to set them and access them. We saw how to write and use methods. And we saw how to make instances of the class. Here, what we're going to do is we're going to do more on classes. We're just going to make another one, a sphere class that's got a little bit more meat to it. And I think this type of stuff, you know, we know enough programming that I think the best way to learn new stuff like this is to learn by doing. Another thing that we're going to see here is that we're actually going to have instances of objects interacting with one another. But more on this near the end of the topic. And the value of having these objects interact with one another is really the abstraction. But we'll get there when we get there. The goal right now, we're going to define a sphere class. Like the circle class, it's going to know its radius. But we also want to know where the sphere is in a three-dimensional space based on some Cartesian coordinate system, x, y, z, okay? That's the idea. So each circle will know its radius, but it will also know its position in space. And we're going to give it some functionality where I can actually ask a sphere, hey sphere, how far away are you from another sphere? And it can tell me. We'll see. That would be an example of interacting objects. Ask a sphere how far away it is from another sphere. I mean, I could do that calculation by asking the sphere for its x, y, z coordinates, asking another sphere for its x, y, z coordinates, and then I do the calculation. Or if I put that functionality inside the sphere class, I could just ask the sphere to do it, like tell me the difference. And that's a nice level of abstraction there. We'll see when we get there. So, in order to define a sphere, all we really need is a radius. And with a radius, we could calculate diameter, and then, you know, because it's a sphere, it's three-dimensional, it's not two-dimensional, it'll have a surface area, and it'll have a volume instead of a circumference and an area, right? But we also want to know where the sphere is, so we're going to keep track of the x, y, z coordinates. And with this information, we can start to perform a lot more interesting and sophisticated stuff and make use of abstraction really nicely. Like I can ask how far away are spheres, do these spheres collide, etc. There's nothing stopping us from adding a hell of a lot more functionality than we're going to. So I want to be clear, with the circle class, if you're thinking to yourself, could you have added a method to do x, y, z? Bad example. Add a method to do some arbitrary thing? Yes, we could. I'm not leaving it, like I didn't stop doing the circle where I did because there was a reason to stop. No, I just did. We could do whatever we want. I can add there. I'm adding a method to this class. It's a terrible method. It doesn't actually return anything. It just has a side effect. It prints out some value. It's pretty ridiculous. I don't recommend it. But I added it to the class nonetheless. Meaning, when I go down here, I'm going to run it. And when I say circle A dot, it's there now. And I can call it. And it does exactly what I told it to. There's no more mystery to it other than it's a function that's inside of an object, and if I want to access it, I have to call it on an instance. It really is just a function, though, but we call it a method, and it's special, right? But really, it just acted like any other function would have, other than the fact that I needed to call it on an instance of an object, an instance of a circle. Cool? All right, so let's go, let's create a new runtime. All right, we're going to start by making a sphere. I'm just going to copy and paste that code, if it will ever load. Great. I hit run. And after hitting run, Python's going to go, oh, okay, they defined a sphere class, and in it there's the constructor, and the constructor wants 4 arguments, x, y, z, and a radius, in addition to the fact that there's that self parameter. So with just this, I can already make an instance of a sphere.